So as Professor Master sir, Professor Sapuristam sir, and Professor Rahul sir mentioned about the Bhasan sir and risks of the cyclone. So I'm going to bit detail on that specific island. My focus is only the island. I'm presenting on behalf of our group. So my topic is tropical cyclone hazard on remote home for the Rohingya at Bhasan Char in Bangladesh. So you already know from this that the migrated people already have in the big camp here, and so Bangladesh government now is decided to move 100,000 Rohingya refugees to a new location, and this is a Char, and this island in Bangladesh called Char. Bhasan Char is located nearby island is Shondip is 4.2 nautical mile, and you can see that it's like a pretty remote island. And so total island area is 11.5 acres, and the camp boundary, the camp government is going to, Bangladesh government is going to build is around like 2,000 acres. So about the land cover, I'm just would like to just mention about the land cover composition of this island. So you can see that like only 1/3 of that island is vegetated, and 60% area is still bare soil, so no vegetation grown yet there. And they have some the channel of the tidal channel mostly. It's not, we should not call it river. It's 3%, and the build-up area 3% is just recently newly developed camp, which is build-up area. So there was no build-up area before. So I'm going to show that. So in 20 years back, you can see from the Google Earth image, high resolution image, there is no island existed in 1999. First, we can see that island comes up a little bit in 2003, and then 2010 it goes bigger, and 2013 we have this like current present shape, a big one and small one beside it, and 2016 and from 2016 on now on, the shape is, the island is like this, shown in the picture. So this island actually within the 20 years course is not stable yet. You can see the movement of the island position and the shape and formation. You can see in 2003 and then 2006. You can see 2009 is shifting in south, 2012 more south, and 2014 is goes the current shape, and 2016 is almost in the same position. 2019 is in the same position. It's stable, but we cannot say it already stable island. So going to the cyclone hazard. So as you see, it is on the path of the cyclone. So cyclones since 1981. I took it 1981 because this is the satellite era of cyclone monitoring. Before that, we have a data inconsistency. So from then, I counted only named cyclone. It's not like depression, not like a small tropical cyclone. So cyclone, when it gets bigger, it was given a name. So 35 cyclone, and you can see that 8 of them is 4 and 5 category 5. This is a huge within 30-40 years. So in Bangladesh coastal zone, you can see there is a western zone, central zone, and eastern zone. So Bhasan Char is like in the intersection of central zone and eastern zone. And I analyze cyclone with return period 5, 10, 20, 50, and 100 years return period, and with the surge height of central zone. So using the Astra digital elevation model in cooperation with a very simple surge decay coefficient model. This idea is very simple. Like when cyclone surge in the coast, it goes like with the same constant surge height, some distance, and it goes height is goes decay is going to smaller when it goes more further. So with this surge height and the constant surge distance and the surge decay coefficient, we model this cyclone inundation, with the different return period. You can see 5-year return period, 10-year return period, and 20-year return period. So surge height is like a low hazard, very low, low hazard, moderate hazard, high hazard, and very high hazard is like a 20-meter apart is class of surge height. You can see 5-year return period cyclone has like more than 6 meters surge height of this island. It is almost 0%. And like high hazard is 7%. But if you go to the 20-year return period, you can see that the high hazard and very high is 30%. And what about the 50 years return period and 100-year return period? So in 50-year and 100-year return period, you can see the majority of the, like almost nearly half of the area is in high hazard area. And one interesting thing is like the current camp location is on the, I think, top ground of the island area. You can see that. So it's a red mark on the camp area. You can see this most, even with the 100-year return period, most of the island will be underwater except the camp area. So that is good in one sense. Another sense is like now there was nothing. We put the element at risk. We had hazard. We didn't have any element at risk. So now we put the element at risk. So together with that, we have risk, cyclone risk on that island. So those are the total population that government is planning to put, like around 100,000 and like 1,440 residential building on that. There will be definitely school and hospital for this 100,000 people. There are cyclone shelter, water and utilities service will be provided, and other public infrastructure, road, and you saw another image in helipad there. And there is a jetty, a small port, and other transport service. So all elements will put there at risk. So this mitigation measure is as the proposed project has like they are planning to have a like 13 kilometer surrounding the camp. So they propose like 2.5 meter high embankment, and they have a wave breaking like a surge breaking wall at the beginning. So and after the foreshore there is a like flood protection embankment. As Professor Islam mentioned that if we don't design it properly, that could be failure. So in image it looks good, right? But we have to put it and design it nicely so that it can really work. And we have like 120 plot. Each of the plot, I mean each red dot is a one plot. So each plot has a cyclone shelter. This cyclone shelter, I doubt, can hold all the people, because they say each building has 16 families. So if you multiply with the number of people, the capacity will be limited. So in addition with that, just few observations. As you can see that lot of tidal channel over there. So those channels can cause lot of erosion during rainy season. So we should think on it how we can reduce the erosion and protect those channels. Secondly, people is not there, but put 100 people there, as mentioned in the Ukiya, Kutupalong camp. I think that 30% forest that I showed in the beginning, that will be disappear soon. So let's have some greenery project along with that. It will help to protect the shore. It will help to reduce the erosion. It will help to make the barrier from the cyclone shelter, the cyclone surge. So we also, not only the building, flood protection wall, cyclone shelter, we also need to design properly for the greenery project and shore project. Like for example, here in the photo, I take this photo from my dissertation when I was in Chile. So after a tsunami, they had a new project to protect the city from the surge height. You can see like they raise the ground, have the walking way, and have the lot of tree with they called it green belt, but not green, like a London green belt to protect the city, but it's a green belt to protect the shelter from the cyclone start, tsunami, and other event, disaster event from there. So that's all. Thank you.
Thank you.
Thank you.